So before we begin, I would like you to think about what edge computing means to you. So just take straight out of Wikipedia. Edge computing is a distributed computing model that brings data processing and storage closer to physical locations where data is generated or consumed rather than relying on the centralized data centers, which in our case means our physical stores or our warehouses. Quick about us. My name is Daniel, and this is Khaled, and we are both platform engineers sitting in the container platform team in JYSK. And how many in here knows about JYSK? Raise your hand. Ah, that's nice to see. Perfect.
Was not expected, actually.
Nice. So yeah, JYSK is an international and family-owned furnishing retailer with Scandinavian roots, more or less based in Denmark. Yeah, and then we have 31,000 employees around the world. And this quote from our founder has more or less become the mentality in the business when we develop things, no matter if it's IT or business strategies, where he's basically saying that even though we back in 2017, we hit 2,500 stores globally, they should not be a barrier for not keep developing. Sure, it's amazing, but we need to keep developing, which means that everything we develop in IT and so on needs to be able to reach amount of 5,000 stores globally, because 5,000 stores is his long-term goal and a vision for the whole company. Yeah, and just a quick overview of where JYSK is present around the globe. So this is kind of phone numbers, because actually this year we hit 3,500 stores, which is a pretty insane milestone for us, where 28 countries is operated by us, and where the rest of the countries are franchises.
Yes. Now we had a bit of time actually to think about what actually edge means to you, but what does it actually mean to JYSK? And we are actually on the edge already. We have 10 large distribution centers closest or all around Europe, close to our stores, and they are quite autonomous. We have automatic picking machines and packing machines and forklifts driving around and by themselves actually. I'm still scared to go there. I'm not sure if I'm not going to get run over by one of them. So yes. But what about our stores actually? Are we on the edge there? Well, that's our goal, and that's what we've been working for quite some time now. And we are still in the beginning of doing that. We're still not developed enough. We had to find actually a problem for us that's going to make us actually go on the edge. We cannot go to management and tell them, you know what, we have 3,500 stores, let's just deploy Kubernetes to each one of them and try to break everything and lose a lot of money doing that. So one of the issues actually that we have is this. This is a really simplified diagram, actually, a network diagram of our stores. So we have stores around the countries, and then we have a central or hub within each country where we have stores, and each store connects to the regional hub. And then that regional hub connects to our headquarters. With the growing number of stores that we're having, we expect we get some bandwidth limitation, especially in some of the countries where the connection is really bad. So that was actually a thing that we came up with. We need to find a way actually of getting the data or manipulating the data in the stores instead of sending a lot of data through the networks to our headquarters. Yep. Motivation. We had to motivate actually our business first, because Kubernetes is a really nice tool, doesn't work for them. They don't understand Kubernetes. We love Kubernetes, we love Talos, that's why we're here. But that didn't work for them, unfortunately. So we had to come up with a simple solution that we wanted to deploy to our stores. And we came up actually with a really simple speed test monitoring where we could actually measure the speed between our headquarters and our stores. It was a buy-in from a lot of business areas actually, because they wanted to see if it's actually the bandwidth that is causing some issues that we're facing. And we got a really good feedback from our customers, which were the stores, which brought us a lot of clear value actually. It was started actually as a one-man project. It was the guy that was supposed to present here with me, which is missing now, unfortunately. He's sick, but yeah, he started it as a one-man project, which we developed now to a full team. Of course, it had to be extensible. We wanted to deploy to all our stores, and it had to fit actually our platform 2.0, which it's something that we came up with. So we have Kubernetes on premises, we have Kubernetes on the edge, and we have Kubernetes on cloud, and we want to streamline the deployments on all of them. We don't want to manage 10 different solutions or 10 different ways of deploying. Yes, the requirements, well, the data processing, of course, needs to be closer to its source. That way we enhance performance, we reduce the latency, of course, and enable real-time insights. We can, of course, utilize the data-driven applications with that actually we can increase the operational efficiency. We can utilize stability and enhance customer experience with that, of course. And one of the requirements actually is the variation to our standards, even though JYSK actually has a really good standard on actually deploying new stores. It still faces some changes because of some legislations that we face in countries, and unfortunately war zones now, because we're also in Ukraine. But yes, the driver, that's
Yes.
something that Daniel will talk about.
So some people might think that really a speed test, can you come up with a better solution for a driver for this project? But when you are in so many countries and have so many stores, you really realize how insane it is, insanely difficult it is to get good connections everywhere. Which means that we just have bad connections, and that's a thing. So we need to monitor it at times, or be able to test at least the speeds in each store, because if a store for some reason has the bandwidth fully occupied with something else, we can sell, we can deliver, we can generate revenue to the company. So to help our customers, could be help desk or our procurement, we came up with this solution, the speed test solution, which is basically a speed test application we developed, and then we deployed that to each store. So we, from each store, actually can do a local speed test and then send the data to some global monitoring. So we have some historical data for it, but we can also, if you see the lower picture, we can also go into our centralized store platform and do an ad hoc test right now if we need to, for instance, for debugging and so on. And this helps the business really much when it comes to figuring out, is there any speed test problems? Are we overloading the networking in a given store or something? And that was, as Khaled said, it was really the big buy-in from the business, which helped us gaining a lot of traction for this. Yeah, Kubernetes on the edge. So this has been quite a journey for us. There have been a lot of thoughts about how we should do it design-wise, and what requirements do we have from our side and from the business side. We had to find a driver for this project, which ended up being the speed test application. And then we had done some POCs with K3s, but I mean, it works, but it's hard to scale, and when you have this amount of storage, it's also hard to maintain in the long run. So we have also been looking into some alternatives like K0s, SUSE Suite, and so on. But yeah, we still struggle to figure out the right way of doing it.
Yes. One of the main issues actually we had with K3s was day 2 operations, and at the end, I mean, as developers, we all know we get really excited really fast, and we just want to develop something and just push it there, and no one thinks actually, oh wait, there is maintenance in that, and we have to actually upgrade stuff, and yeah, like that's something that we fall in that trap quite often. But yes, day 2 operations, that's really important actually. We need housekeeping, we need maintenance, we need upgrades, and doing that in 3,500 stores, it's not the bash script, or it's not a manual process. So We need something. We need to come up with something. And also another thing that we actually forget is the end, delete and clean up. When being on the edge, not cleaning up means that you're clustering your servers really fast. So that's a thing that we need to think about, of course. How did we fix that? Well, we came up with a deployment design. On my right, your left, we see a store design where we have a server, point of sale devices, and some handheld devices, and of course many other things. But on the servers, that's where we're running, of course, our Proxmox host. And we came up with a design where we want to either replace a node, because we want to restart it wherever it is, and upgrade one. We have decoupled, of course, the networking and the storage, so we can do that actually on the fly without disturbing anything. The restart process, it just goes through, of course, spinning the same image that we have already on the Proxmox host, spinning a new one, and removing, of course, the faulty one if it's faulty. And the upgrade path is we get a new image to the host, spin a new node from the new image, and then kill the old node. Then we come to the deployment, actually. How do we do that? How do we manage that? Well, we utilize, of course, the hypervisor API. That way we can actually either create a highly sophisticated bash script, like we all do, or utilize a tool like Terraform, which is going to actually allow us to scale. But we came up actually with a third solution, which is much better than those two, and that's just give the work to a third team. We have a third team actually in doing that for us at JYSK. Of course, that's something that we want to change for the future. Deployment process. Well, that's how deployment goes. That's a hairy diagram. That's depending on if we want to actually deploy a new node or we just want to start the Talos. Let's go through actually the process of starting a new node. You can see that actually we have a backend service. Well, that's our own built-in-house backend service that we started off. As I said, we are still in a POC phase, so we haven't looked much into Omni, but that's probably where we should go if it meets all our requirements, which Daniel is going to talk a bit more about. But let's start actually deploying a new node. Of course, we go to the Proxmox virtual environment and we just run the image, and then Talos is going to go into maintenance mode, where it's going to try to figure out, okay, do I have all the configuration that I need in order to start? Of course, it doesn't, because it's a new node, so it's going to go and try to provision itself by contacting the Talos Provision API, which is also going to actually try to figure out, do I have actually something in the database for the node contacting me? It doesn't have, so it goes into actually contacting all our backend or third-level APIs. It collects the data for all the data that we need in order to spin up a node, bundles all that into a Cloud Init manifest, which then the node actually can fetch, start itself, start Kubernetes, and then our GitOps picks up, where we actually have 3 levels of reconciliation. So we can deploy globally to all nodes at the same time. We can do that on a country level, and then we can do that on a single store level. And deploying that on the global, don't try it with 3,500 stores. We faced a lot of issues which we luckily fixed. But you can read more about that in some articles we wrote about.
So, as mentioned before, when spinning up a new cluster, the node is contacting our Talos Provision API, which is a self-built provision API, because when we started this whole project, we looked into things like Omni, but Omni couldn't fully suit the requirements we had, so we had to come up with our own solution, which ended up being this. So it's a small API built on Go, but uses the Talos Upstream SDK, and then it has OAuth2 proxy in the front for authentication, both for the nodes, but also if you're using it through the CLI. And then it has a Postgres database in the backend for storing configs, both for Kubernetes and Talos, which means that if a node already is present in the database, it will just contact the API, pull down the config, and boom, it gets installed. And then it also provides a cloud init manifest for the stores. So when a new node boots up, it generates a cloud init manifest for the node, which it will be configured from. And then everything is just on the fly. Yeah, and some of the things we had issues with when we looked into Omni back then was like integrating with the third-party APIs. So for instance, when we generate config for Talos, we are using our netbox for getting IP informations. And then we have also information from our CMDB and from our third own in-house built store APIs. So now we have a self-built solution. And that's actually quite good for us compared to where we are now, because now we can have a solution where it is built for our needs. We can easily add custom logic to it because as many big businesses, JYSK is also changing rapidly, which gives some more flexibility when it comes to developing features. We can deliver certificates and configuration and modifications on the fly to the clusters. We have some authentication workflows for delivering configuration, but also through the CLI we have, where we just can say we want to get config from this cluster, both Kube and Talos, and then we get it down, and then we can connect. Yeah, it's very small, extensible, so it can easily integrate with other APIs in our landscape. And then it can support bots and hooks and notifications. It's definitely free to run, not to maintain. That's what you get when you do self-build, but yeah, that's what you got to be used to. Then it relies on Talos SDK for upstream compatibility. So what alternatives do we have? So far, we don't have any, because we have still requirements which can be fulfilled by other products. Even though Omni can do a lot, it can't do everything for us right now. So is this even enterprise ready? I mean, we're running it on plus 3,000 stores, and it's maintaining it on a day-to-day basis, and it's fully functional. So from our side, it is actually.
Yes. Of course, we still have some issues with the solution. As I said, this is nowhere near actually production-ready system. We should think about scalability, of course. We are running, I don't know if you could see anywhere, but we are running actually a single node clusters, which it's not a good idea on running production workloads. Vendor lock-in, we are vendor locked. We are locked to ourselves. That's, you don't need to pay someone to be vendor locked. So when you use your own API, and try to maintain it and upgrade it all the time, that's vendor locking. So yes, we are vendor locked for now. We want to go out of that, but that's where we are. Day-2 operations is still not really satisfied, as I said. We are relying on a third level or third team to deploy our images. And we're replacing nodes because, of course, we're running a single cluster. And our hardware is not really meant for running too many Kubernetes clusters at once. We're not harvesting logs. And GitOps, if we're going to go to Argo CD, maybe yes, maybe no. That's something that we need to still think about. But as I said, it's a really still really long way for us until we get to a full production system. But going forward, actually, the business is happy with us. It's happy with what we did. It's happy with what they see from us. So we are going to grow. The team is going to grow. Our ideas are constantly being generated. And we get actually teams from within the company that are interested in our product, and they want to actually get into it and start using it. Yeah, I think, did it work? I mean, yes, it did work. It's running. I mean, we also have application running on it. is it ready? No, it's not ready. So yeah, that's if you want to read actually a bit more about the things that we did that we haven't covered here, there is a JYSK Tech, or the articles. We've written a few articles about it, so you can go and check those ones.
And there's also a lot of other articles about what other tech we're doing in JYSK. It's not only Kubernetes, it's also a lot of other things. So go check it out and have a read.
Yes, thank you.